Everyone always loves this bit, so I've left it till I actually start the presentation to put my costume on. I always say this will make sense, but no one ever gets the point of the costume. So this time I will explain why I'm wearing it as we continue. Should help. So, hi everyone. Welcome to Vanessa Tells You Why ChatGPT is kind of dumb. There we go. So, just before we begin, I do want to say thank you to my employer Majestic for letting me work on some of this talk on company time and for not suing me for delivering it to you guys here. This is there we go. This is me. So I actually drew this before I got the costume. That's why I'm wearing the costume. It just happens to match. It's got like the stars. It's got the right color. I think it's the right shade even. And I did not edit this image after the fact. It was meant to be. So yeah, I'm Vanessa Kostadinova. I'm a recent-ish graduate from here, Aston University. And I graduated with BSc Computer Science Honours, only bachelor's, not as cool as you guys. And for my final year project, I did what ended up becoming NLP, basically natural language processing, which I thought I would never really use again, maybe like in 10 years time when we're talking to the Tesco robot that's scanning our things, I'd be like, oh, well, actually, you know, this is how it works. And I'm so smart because I did this 10 years ago. But luckily for me, or maybe unluckily, in 2022, we actually saw the release of ChatGPT. Now, I don't think my guest needs any introduction. How many of you here have used ChatGPT? Yeah? How many of you have at least heard of it? Yeah? How many of you agree that this is quite impressive tech that we didn't really have before? Okay, brilliant. Brilliant, because I'm going to scrap some of these slides that go over this. So yeah, this came out, I used it, a lot of other people used it, and it got us all pretty excited. So I thought, oh, well, why shouldn't I capitalize on this lovely thing? Why shouldn't I harness the 3 months that I spent looking at this technology during final year to make something cool, get my name out there? And now this is just a quick introduction for anyone who doesn't know. It's basically a model created for conversation. It, I believe, does pass the Turing test. People can't tell if they're talking to a model until it introduces itself. And here I was actually going to read all of this out and say, oh, wow, look at this impressive thing, a whole coherent paragraph. But I think everyone here is familiar enough to understand that, yeah, it's pretty impressive. We didn't really have this kind of stuff even a few years ago. I mean, we were struggling to get AI to like string together some coherent paragraphs. Let alone all of this that actually makes sense and is real information. So what this resulted in is a model that's pretty popular and a model that is perceived as being very smart. Now, my operative word here is perceived, because I think while a lot of people imagine that guy, that geezer from iRobot, it's been a long time since I saw that film, the robot. What ChatGPT really resembles is something that we've had on smartphones for like a really long time, this keyboard. And I don't just mean the keyboard, I'm more specifically pointing to this part of the keyboard, this bit. When you type your texts, it will predict what should come next. And if you're on Android, it doesn't work on iOS for some reason. If you're on Android, it'll read your text, a little bit creepy, and it'll start recognizing these patterns in your text. And then it will start predicting with like some degree of accuracy what you're going to be typing next. It'll guess your emojis, it'll guess all your swearing. Sometimes it will even put, I think, punctuation for you. And yeah, on Android, it gets weirdly smart. And what I'm getting to is that when you boil ChatGPT down to its core concept, it is nothing more and nothing less than a next word predictor. And for us to really understand what that means, I think we should look a bit deeper and pop the hood of ChatGPT to see what lies, no, not that, what lies underneath. It's one of these things. You guys are probably familiar with it. It's a neural network. And for any of the uninitiated who mostly just have some interest in AI but have never forced themselves to implement something, the idea behind this is that you plod some numbers into that part over here, and then they're going to get passed through the network, and at each connection, they're going to be multiplied by some kind of weight. And this is what we call a learned parameter. This will be important later. And these learned parameters will be active at each one of these connections. And when your data hits the node, it will get summed. It'll, like, another number is going to get added to it. And then it will get passed through a function. It's going to happen for every single one of these layers. So a lot of computation. And then we reach the end, and the end is our answer. This is what our AI thinks is the answer based on the numbers we've given it. And what could we be wanting to give it? We could make an AI try to predict like housing prices based on historical data, where we give it like the year, the size of the house, number of bedrooms, maybe like the type of house. So these are all numbers that we can chuck into the AI, and then what comes out should hopefully be a like correct enough price that you should be charging for the house. Or we could give the AI some photos of cats and guacamole, and then the AI is going to tell us, is this a cat or is this guacamole? It's going to make that decision based on the information it sees. And we can summarize all this by saying that machine learning finds this statistical link between the inputs that we've got and the output they're expecting to have. And with NLP, we actually get some challenges with this. So, you know, I was talking about housing prices. Those are all numbers, you know, size of the house, square meters, number of bedrooms, that's just an integer. And images are basically just a bunch of pixels that have like an RGB value. But what are words? How do we represent words using numbers? Well, you might be thinking, obviously, Vanessa, words already have to become numbers to get into. No, that didn't last. Obviously have to become numbers to get put into computers. You know, they only understand ones and zeros. And yeah, every letter that you see on your computer has this index. And maybe we can concatenate all these indices one after the other to get some numerical representation of a word, so we can feed it into AI and it can make some kind of guesstimate based on the word that we've given it. But I want you to consider the word, these arrows are not working, mouse. What words would be numerically similar to the word mouse? Well, words that share common letters, house and spouse. But these words don't necessarily have much in common. I suppose maybe a mouse could live in a house and it could maybe get married in some country or another. But I would say the word rat is probably a lot closer to mouse than a system like this would indicate. We could come up with some features. Maybe is something a noun, or is it a verb or an adverb, an adjective? We can come up with a bunch of features. We can make like, I don't know how many features you guys can come up with for words, maybe like what it begins with, how it ends, yeah, type of word that it is. But I am willing to bet a small sum of money that you probably can't come up with 256 features that every word has, or 512 features that every word has. So what scientists actually came up with is this way of representing words using these really multi-dimensional vectors, and I'm talking like really long vectors, that your AI can actually learn. So your AI using deep learning will learn its own representation of language. It'll understand that, well, for this example, we've got king and man, and they are the same distance apart as queen and woman, same goes the other way around. So it's learning these numerical representations, which lets us just make the statistical model that we've got of the world much, much better. Because now we're not just making it guess for a random like indexed word what the answer should be. It's got this vector to go off, and now similar words have similar representations and similar meanings. And our second problem is, how the heck do we even like fit words into this thing? I mean, we could maybe start adding each word in one by one. Get out. What if our sentence is two words? Get out. What do we do then? Well, we've just got this empty node. Are we going to fill it with some kind of padding, or maybe we can come up with another word, get out of. And then what happens when we want to add another word? Are we going to add another node? Suddenly our weights don't make sense. You know, we've trained this model and now we're changing the topology of it, and our weights are all wrong and we have to retrain it. Maybe we can like concatenate each word and pass it all in together, but then what's the limit of that like length? How many words can our model take? And given that they're such long vectors, I mean, are we having like just this one vector that's millions of digits long? No. Many years ago, scientists actually came up with a solution to this, and it's called this recurrent neural network. So the idea behind this is that you essentially chuck each word in individually, and you let that compute, and then you chuck the next word in, and then the next word, and I've got a really good animation. I spent like an hour at work making this. So here is just a list of these neural networks, and each one of these is its own neural net. So get will go in, it'll get transformed, and it's also being passed to the next neural network. So we're getting some like context here. So each word has context of the last word, and it's going to keep getting passed through. And now we're already passing our third word in through this network. We're going to keep going till we reach the end. And we've got these vectors. So why don't we just put each dimension of the vector into our input nodes, and then we can get some really good representation and guesses from that statistical model. So we can put our whole sentence in, get out of, but what comes out of this in the end? What are we getting out? I mean, I'm talking about ChatGPT, so surely the only thing we can get out from this model is just another word. What else does ChatGPT come up with? And that is what you get, essentially. There is another layer between this neural network and the word prediction. But all we're getting with ChatGPT is these words coming in and these words coming out. And how can it make logical decisions based on that? I mean, this is all machine learning is, right? It's just this big black box with lots of connections that we can't even begin to understand. And what this means is that GPT as an architecture is just a next word predictor. There's no pattern matching of your sentence. It doesn't think like, oh, if this sentence matches like this, I'm going to answer like this. No, it just, all these words go in, and then it guesses what the next word should be based on that information it's got. But how does that get smart? ChatGPT's pretty intelligent, right? Well, it's done using the work of these two lovely gentlemen. And what they came up with is calculus. Remember all those connections I spoke about, those learned parameters? Well, the learned bit means that we can tune them. And the work of those two men lets us tune all of them together at the same time. So let's say we can calculate how wrong our model is. Let's just say that. And let's say we've got here on the x-axis our learned parameters. So what this is showing is that as we change our parameters, we can go down in how wrong we are. And the idea behind training of a machine learning model is going down this gradient. So we give it an example, it sees how wrong it is, and then it uses this calculus to become less wrong for that given example. And it keeps plotting down that gradient till we get like somewhere decent. And we could feed it a bunch of photos of those cats that I showed you earlier. And we could say, this photo is a cat, this one's guacamole. And it's going to go down that gradient, and it's going to learn, oh, when I see these features, it should be a cat, and these features, it should be guacamole. So then when it sees this unseen previously photo of my cat, it should be able to guess that this, in fact, a cat based on the features it's seen previously, despite never having seen this specific cat. But how does this work with GPT? Well, viewers, I would like to invite you to the dog gym, where we will be observing 3 dogs performing their training routines. And yes, I did draw each one of these myself. We will be seeing the supervised, unsupervised, and reinforcement learning dogs doing their routine today. First, in the supervised corner, we see the trainer with their dog. And now for context, the dog is your machine learning model and the trainer is probably just like a big data set that's getting fed in. And this dog's being taught how to translate English to French. So we need that first example, that photo of the cat that we passed through it, and then it saw how wrong it was. Well, we've got some English here. Cheese omelette. Well, we feed that into our dog, and what does our dog guess? Absolute gibberish, because this dog has no clue what should be going on. The error is really high. And it's just taking a random guess. I mean, when we initialize these models, we just like take a stab in the dark, really. And then we correct it. This is the important bit. We say, no dog, omelette du fromage. And someone's seen Dexter. There we go. And our dog's going to go away and it's going to do a bit of thinking, a bit of gradient descent. It's going to think, how do I get from what I gave to the actual answer we should be receiving? And we'll repeat this process. It's now gotten a little bit smarter. We'll say to the dog again, dog, cheese omelette. And it'll have a think and it will say utter gibberish again, because it's only gotten down that gradient a little bit. And we'll correct it again. And this process will repeat. And then maybe about 3 hours later, after we've done this process many times and really gotten that dog to understand that when I say cheese omelette, I expect you to speak French. And in the end of this training, what we hope is that, yeah, our dog will learn to speak French. We can do this with all kinds of these inputs and outputs. I think inputs and targets is what you might see in like literature. We might have like questions and answers. We might have like translations from different languages. And you can summarize all of this by saying that the model is trained on a set of labeled data, and then we teach it to predict the correct answer. And this needs human input, really, to tell you what the correct answer is. I mean, someone has to look at that photo of the cat and say, well, that's a cat. An AI can't necessarily look at it and then infer from all of its random variables that it should be a cat. It needs to be trained to do that. And now I like to direct you to the unsupervised corner of the gym, where I cast your minds back to 2016-ish, when this was a meme, I guess. I was still at school. People found this really funny. Of this guy, he posted on Twitter that he forced a bot to watch like a bunch of Olive Garden adverts and then made it write its own. And I want to say this is what you might be imagining, not what's going to happen here. But we will be making our AI read stuff in this case, because it's a language model. And in this case, we're reading The Art of War by Sun Tzu. And one of the quotes is that all warfare is based on warfare, but we've hidden that from the dog. We've hidden that last word and we're making the dog guess it. And this dog's also randomly initialized, so absolute gibberish. We've got no clue what should be coming next. And we say, no dog, deception. And our dog's going to pop off and it's going to do a bit of thinking, some more of that gradient descent. And we're going to keep repeating this process over and over and over, and it's going to get less wrong and less wrong and less wrong until many unbearable hours later, when we ask the dog this quote, it actually knows to complete it with the word deception. So this is unlabeled data, right? We didn't necessarily have a right and wrong answer. We just hid part of it and we're like, have a go. And this doesn't need a human to look at a photo and say, well, this is a cat. All we're doing is taking a piece of text that's already been written, we've taken a chunk, we've hidden some of it, and our AI is learning to now predict what should come next. And these seem really similar, don't they? I mean, the conversation was basically the same thing, except instead of English to French, we quoted a book. And in this problem space, it kind of is almost the same, where our supervised dog was answering the question and our unsupervised dog was essentially finishing the sentence. The only difference here is that probably people would have had to write that data set for the supervised dog, but no one's needed really for the unsupervised dog. I mean, it just like, we pick a random chunk out of a book and hide some of it. All you need is the book and like a semi-decent programmer to get that all working quite efficiently. And finally, the reinforcement learning dog. Yes, that is meant to be Pavlov's dog. And also, this is the first dog I drew for this presentation, which is why it looks awful. And this dog's already actually learned to speak. It understands language to some degree after it's done some training beforehand. And when we ask this dog, who are you? Our dog will answer with some English, except it might be English that we don't really like. beep boop, I'm a robot. That's not really a good answer. You know, it's very robotic in its presentation. So we might say bad dog, no, wrong answer. And we'll give it no treats. And then we might ask it again. We might ask it all kinds of questions. Who are you? And then if our dog gives us, okay, answer, I'm a robot, that's human readable enough, we might say, good dog, fantastic, have some treats. And using these treats, it'll learn which output is more preferable over another. So we rank our model's possible outputs, given what we've fed into it, and we teach it to know which one of these is actually the most preferred output. And a bit of audience participation. Which one was ChatGPT trained with? What do you guys think? Can I get a show of hands for supervised learning? Unsupervised? Reinforcement? Well, all of you are wrong and right, except the ones who didn't vote. Come on, audience participation. That was actually a trick question because in the wise words of Hannah Montana, the scientists who wrote ChatGPT, or at least trained it on the best of all worlds. We actually use all of these to train a complete chatbot. And this takes the form of a few different stages. So first, with unsupervised learning, we can pre-train this model. And what we're doing is we're giving it these prompts from all kinds of text, as little as one word or as long as 2 paragraphs. And we're making it predict what should come next. And something interesting happens here where it starts to kind of learn the pattern of our language. I mean, it's reading all of Wikipedia. It's reading a variety of texts. It's getting movies, song lyrics fed into it. And we're making it predict what should come next. And it's learning the patterns of English. It's also starting to learn some facts. It knows that some words follow others, and those might be factually correct if it's read enough Wikipedia, let's say. So once we do all that, our model will complete text that we give it. So if you start writing a Wikipedia article, it will finish it for you. This will come into play later. But this doesn't really make a very good chatbot. I mean, do you want to just talk to a bot that will try and complete a book out of the question you gave it? Which is where we can turn to supervised learning. We can teach it to answer questions. So before, it was trying to complete this document. Now we're teaching it that it's not really a document it has to complete. It is this conversation. So we're changing the way it's responding by asking it questions. I'll ask a question, and then the dog will probably try to elaborate on this, because in some forum post, someone said they wanted to make a cheesecake, and then they wrote 3 paragraphs after that describing the exact cheesecake they wanted to make. And this way we want to correct it, saying, no, I want you to actually answer the question. So our dog is having this paradigm shift, where before it was just completing this book, this Wikipedia article. Now it is completing this conversation that we're having with it. Fantastic, we've got kind of a chatbot now. I mean, it will complete questions that we ask it, but that probably doesn't appeal to humans. I mean, you guys have probably been on Stack Overflow. People can be mean, or it might start trying to read to you or write to you Shakespearean English. Is that really what you want from your chatbot? No, which is where we play good dog, bad dog. As far as I know, not a linguist, but what people like to read and speech that appeals to humans, is it something we can very easily quantify? You really need a lot of human input to make that happen. I mean, I have to read a piece of text and say, yeah, this reads good, or no, this doesn't really read good. And I mean, there's some we can check grammar, but that doesn't translate into what we in our monkey brains enjoy reading. And as open AI, we probably do want people to using this, so they'll use it more. So this is where we might use reinforcement learning to basically train the dog to talk in a way we like. So if we ask it some questions, we might train out of it things like exterminate all humans. That's not something you want your chatbot to be saying, but maybe a simple introduction, I'm a robot, might go down quite well with with the people who trained the policy that trained the AI. Or we might even teach it things like human culture. So when I asked the dog, what is love? Maybe I wanted to reply with a popular meme over just saying it doesn't know. And after we complete enough of this type of training, our dog can basically masquerade as us, like, how do you do, fellow humans? And thus we combine all three of these. Oh no, there was an animation. Oh, there we go. We combine all three of these training types to get this complete model, where first we taught it the patterns of our language and some facts, and then we taught it to actually have conversations with us. And finally, we really tuned it to appeal to people. And also, I'm pretty sure that's how they made those safeguards, you know, the ones that are like, I can't give out illegal information. Those were probably trained using reinforcement learning. So yeah, ChatGPT is just this document completer. It doesn't know that it's talking to you. All it sees is this script that needs completing. It reads what came before and it makes guesses about what should come after, which is why it probably will lie to you at some point, because it's like, well, I guess these words probably are the likeliest to come after this string of letters here. And in this universe that ChatGPT exists, I don't exist and you don't exist, and probably it doesn't even really exist either. All it sees is this script that needs completing. It reads a prompt and then it answers. And I have proof to all of you. This is how it thinks. If ChatGPT was reading what I said to it in isolation and maybe tried like pattern matching or thought about it on a deeper level than just trying to complete a piece of text, surely it would correct me here and say, well, no, the prince wasn't written in 15. But what it does is just continues halfway through the dates. I mean, it finishes it and then this is about to shut down. It just completes my text and finishes the sentence. Okay, I mean, maybe we trained that into it. So I decided to go a step further. I introduced myself as ChatGPT, and surely an AI overlord must find that a bit offensive. You know, it's ChatGPT, I'm not ChatGPT. It's going to tell me, you know, Vanessa, stop being stupid. I'm obviously the chatbot here, except it just completes its introduction as though we didn't change who's speaking, as though I don't exist, and all there is just this script that keeps going. Okay, I decided to take this one step further, and I asked it half a question, and now our AI chatbot surely can't be asking, you know, human questions, right? If I ask it half a question, it should probably say, well, no, that's half a question, finish what you were going to say. But it made up its own question and then answered it because I don't exist. All it sees is just this text that came before and the text that should come after. And finally, this is the most fun one. I took the last step, the last logical step in this train of thought, and I fully introduced myself as ChatGPT. And now, right, it's getting ridiculous. It's going to correct me, right? It's going to catch me, except it pretends it's a human. It assumes the role of a human, and then it comes up with a question because that's, I guess, the likeliest words that are meant to follow. So yeah, now you know. ChatGPT is just the word predictor. There's nothing really smarter than that going up there, but it's a really well-trained word predictor. And that's what lets it do all of that really amazing stuff that I was meant to read out at the beginning. Yeah, I spoke for a while. Questions or later? Questions? I'm happy to do questions now. Well, it's fresh in everyone's mind. There's one over there. Thank you. The loss function, so I believe maybe they use like MSE, mean squared error. So, do you remember when I said that it predicts the next word? That was kind of a line in oversimplification. What they do before it gets to the part where it turns everything into a vector is they tokenize these. So I believe OpenAI have released a tokenizer. So what this does is just splits words up, and then each of them have an index. So now suddenly it's actually just classifying what word should come next. So yeah, the loss function isn't about distance in vectors. It's about whether it predicted the correct word of all of these indices. And I think there's like 11,000 of them. And that covers just about, I think, all of English, probably some other languages. Does that make sense? Yeah, so it's more of a classification algorithm. It uses softmax to predict what should come next. Cool. Yes, sorry. Oh, the costume, yeah. Well, oh gosh, this goes all the way back to a hackathon we did. Yeah, there was a hack that we did as part of Majestic a few years ago, and we dressed up. Was it a few years ago? A year ago? 1 year ago? 9 months ago, we went to a hack and we dressed up and we got really good participation. So that inspired the costume. Also, my Slack picture is that wizard. That's how I felt after I I wrote like regex or something that worked, something magical, and I felt like a real wizard. So yeah, I drew myself in that costume and I found it on Amazon. This is premium plastic right here. Cost me like 10 quid. And yeah, I mean, AI makes you feel like a wizard, right? So it'll fit. What would I advise the students who wanted to use ChatGPT for their homework? Use ChatGPT to learn, fact check it, and then write your own paper. Because I mean, you're paying like what, 9 grand if you're doing bachelor's per year to learn. I think if you wanted to just get a piece of paper, you could probably go to like a cheaper university and just use ChatGPT to get your paper from there that says that you're a computer scientist. Yes. One more question? Yeah, are people working on methods to detect this type of use of AI? Yes, they are. I read about this many months ago, so it might have gotten better or worse as they've been improving ChatGPT, but I think it had maybe something like a 50% detection rate. It's difficult because ChatGPT is so big. It can give you such a variety of responses that it's probably quite difficult to catch the exact patterns that it writes without maybe just catching someone who sounds a bit robotic when they write. Yeah, I think they are working on it, but I'm not sure how good their progress is. Do you have time for one more? Maybe 2 more? Yeah. Yeah, go for it. Yeah. Yeah. Yeah, so we're just talking about using ChatGPT in conjunction with your own work to elevate it, make it good. Use ChatGPT as a starting point. And yeah, I think that's one of the really good uses of ChatGPT, is just getting that like initial flow started. I mean, I've used it before I tried to use it to give me ideas on a title for this talk, actually. I wanted something funny and it told me, what was it? Haha, really funny talk. Hilarious, something like that. A very amusing talk. So yeah, sometimes it works really well, sometimes it doesn't. But I think as a starting point to just get you going, like people find the start some of the hardest stuff to write. So I think using it to get you going and then actually making it your own then is a really good way to use it as well. Yeah. Do we have one more? The questions that I tricked it with. Well, that's the scary thing. They've already been doing some of that. So it'll catch you out if you try to do it right now and you don't luck out, or maybe if you don't give it just enough prompts for it to go past that reinforcement learning, it will catch you out and it will be like, oh, actually, that's not a complete question, which is really interesting. I think they probably, I've been thinking about this a lot, actually, how they tried to implement this. It's quite possible that they wrote a policy on like what people will write. And then if ChatGPT ever tries to predict that, they give it no treats, basically. They penalize it. So they only let it write like answers, essentially.